Did you know that water is also one of the main foundations for the formation of life? Therefore, any potentially habitable planet must have water to support life. And to have water, that planet must satisfy many conditions. For example, it must lie within the star's habitable zone. At that distance, the temperature and atmospheric pressure on the surface will be suitable for the evolution of simple life forms. If it orbits too close to the star, the water will evaporate, and oceans or seas would never have the chance to form. This is exactly what happened to Venus. It has a size and mass similar to Earth, but because it is too close to the sun, no form of life can exist on its surface. When a planet is too far from its star, its climate will be extremely cold. Water on the surface can only exist as ice, and you would have to go deep underground to find liquid water. Neptune is an example of this. Additionally, the planet must be solid and have an atmosphere to protect itself from solar radiation, as well as allow living organisms to breathe. In our galaxy alone, there are countless stars. You wouldn't be able to count them. Nearly every star may have at least one planet. These are called exoplanets, and some of them lie within the habitable zone and possess the necessary conditions for life to form. From the list of 4,500 known exoplanets, scientists have identified 24 super-habitable planets, worlds even more suitable for life and evolution than Earth. Such planets must be twice as heavy and about 1.3 times larger than Earth. Their larger size means stronger gravity and a thicker, warmer atmosphere. This creates an environment where life forms could be even more diverse than on Earth. We must also pay attention to the host star that these super-habitable planets orbit. Ideally, the star should be smaller than the Sun and have a lifespan of 15 to 30 billion years. For comparison, the Sun's lifespan is less than 10 billion years, and it took about 4 billion years for complex life to appear on Earth. Similar stars to the Sun may run out of fuel before life has time to form on their planets. Scientists suggest focusing on red dwarf stars. They are smaller and emit less light than the Sun, but their lifespans can reach 20 to 70 billion years. This gives living organisms plenty of time to form and evolve. The climate on superhabitable planets will also differ. Their average temperature must be about 4.5 degrees Celsius higher than Earth's, and they must have more abundant water in the form of clouds, liquid, and moisture. These conditions are most favorable for ecosystems, making the entire planet resemble Earth's tropical rainforests. All 24 candidates for better-than-Earth worlds are more than 100 light-years away from us. With the arrival of a new generation of space telescopes, we may soon find out whether they host life, or at least conditions suitable for humans. Now, let's take a look at some exoplanets with potential for life. Teegarden B is an exoplanet, orbiting a red dwarf star about 12 light-years from the solar system. Normally, red dwarfs can produce flares capable of stripping away a planet's atmosphere, but this particular star is calm and relatively inactive. Teegarden B has a mass nearly identical to Earth and completes one orbit in about 5 days. Yes, you heard that right. A year on Teegarden B is shorter than a week on Earth. The farthest potentially habitable planet is Kepler 438b, located in the constellation Cygnus about 3,000 light-years away. It is classified as a super-Earth twice as wide and 4 times heavier than our planet. Therefore, gravity there would be much stronger. Even a simple jump would be more difficult than on Earth. However, if life exists there, the organisms would already be adapted to those conditions. LHS 1140b is a very dense, although its size is only 40% larger than Earth's, it is 7 times heavier. It has a strong gravity of up to 3.25 g. For comparison, during an airplane takeoff, you experience about 1.5 g on this planet. You wouldn't even be able to stand upright. Because of its mass, the planet has a thick atmosphere, and due to the greenhouse effect, its temperature may be above -7 degrees Celsius. It also orbits its star quite quickly, completing one orbit every 24 days. Now let's look at the constellation Aquarius, where there is an ultra-cool red dwarf star named TRAPPIST. In its habitable zone lies a small planet lighter than Earth by 30%. Its temperature is similar to Earth's, but its gravity is only half as strong. You would still feel comfortable there. Just remember the astronauts who walked on the moon. its gravity is only 16% of Earth's, making their movements look very funny. Kepler 452b belongs to a system similar to ours. Its host star is only 11% older than the Sun, around 2 billion years in age. The planet itself is 6.5 billion years old, compared to Earth's 4.5 billion years. But these two stars are incredibly far apart. If you traveled toward it at the speed of NASA's New Horizons probe, it would take you about 26 million years to get there. So don't forget to pack a very large lunchbox. The closest exoplanet to us is Proxima Centauri b. It orbits the red dwarf star Proxima Centauri, the closest star to the Sun. This planet is only 4.25 light-years away from us, and is similar in size and mass to Earth. It has an icy composition, similar to Neptune. Although Proxima Centauri is our nearest star after the Sun, we still cannot see it with a naked eye, because it is too dim. All these planets, including D24 superhabitable ones, recently identified by scientists, lie within the habitable zones of their host stars. Theoretically, we could settle and terraform them to suit human life in the future. But we still face a major problem. Even the nearest exoplanets are incredibly far away. Modern rockets can travel at 5 times the speed of sound. But at that speed, it would still take over 100,000 years. To reach Proxima Centauri, we need something faster, much faster, to get to a new home on one of these exoplanets. And perhaps scientists already have an answer. It's the warp drive. This technology would allow us to manipulate space and time. It creates a bubble in which the normal laws of motion do not apply. As a result, a spacecraft could travel at speeds far greater than the speed of light. And no, this isn't science fiction. Humanity has already theorized such technology, at least on paper. This is the Alcubierre warp drive. And no, I'm not making it up. Since no object with mass can travel at the speed of light, we need a trick. The spacecraft moves by compressing space in front of it and expanding space behind it. It's not just the ship that's moving, it's the space-time bubble around it. The maximum speed could reach 10 times the speed of light. But to bend space-time, the ship must be extremely large, and operating it would require an amount of energy nearly equal to the output of Jupiter. However, recent calculations by NASA's Jet Propulsion Laboratory suggest that the rings surrounding the ship, which generates what is called the warp field, should not be perfectly circular but shaped more like a donut. This would simplify the design and construction, allowing the technology to be tested on a spacecraft the size of the Voyager 1 probe. Although it seems impossible, scientists remain hopeful. And even though we still do not know which technology will ultimately be used, NASA has already planned its first interstellar mission for the year 2069 to explore planets outside the solar system that may host life. Many speculate that light-speed travel might be achievable using laser-powered microprobes, which could be accelerated toward Alpha Centauri at near-light speed. There are also 2 other potential power sources for spacecraft: nuclear energy and energy produced from matter-antimatter collisions. However, these technologies remain a mystery to humanity for now. Well, for the time being, just stay tuned.